now we want to demonstrate the label detection or the label gap detection with our optical fork sensors. In this case, we can see the GS63 with the teach button. Of course, we also offer versions with a potentiometer, like in this case, the smaller GS61. But I think to demonstrate, everybody knows how to work with a potentiometer, so in this case I want to demonstrate how it works with a teach button. So what we can see here is a simple, non-transparent label, and in order to teach this label on the sensor, I just press the teach button for 2 seconds. Now I can see that the 2 LEDs are flashing. This means the teach process has started, and now I just spend some labels through the sensor, and the sensor is recording the signal of the label and the label gap, and after that I just press the teach button again and the teach is finished. And now I can see, if I go through the label, I can see that the sensor switches on in the label gap, meaning that the sensor is reliably detecting the label gap of this non-transparent label. Obviously in the market we have several different kinds of labels. So for example, what we can see here is a very shiny label, but also non-transparent. So if I just put in this label in our sensor, we can see that the label gap is reliably detected without any problems. And in this case, it was not even necessary to teach the sensor again on the new label format. It's just working. So another example would be some bigger label. I think in this case it's of a good wine or a whiskey, but also it's non-transparent, and therefore you can see that there are not any problems for our GS63 in order to detect the label gaps here. But obviously on top of that we also have different things. What you can see here is a thicker label that is also metallized. So we can try how this will work with our GS63. And now I can see it still looks good, and the label gaps are detected absolutely reliably. And everything works fine. And so we have also one special case. If we look at this kind of label, I think at first it just looks like a normal non-transparent label, but in this case this label is made of a special material called cavitated BOBP. This means this label has a somehow inhomogeneous material with tiny air cavities on the label itself. And so we will see how this works with our GS63 and if it's possible to detect those kind of labels. And again, what you can see here is that even inhomogeneous labels can be detected absolutely reliable as long as they are not semi-transparent or transparent. And now we are coming to, let's say, to the labels where we possibly need another solution. So if we look at this one here, we have a transparent label carrier and somehow semi-transparent label itself. So I don't know, it's for some shampoo or something like that. But if we try to detect this label with our GS63, we can see that we have problems because the sensor cannot detect the difference between the label carrier and the label itself. So I can try to teach the sensor and see if we can optimize something, if we just record the specific signal of this label. But also you can see here that we get multiple signals also on the label itself, just because of those transparent parts. And so in this case, if we have semi-transparent labels, or if we even have something like that, which are really fully transparent labels, we need another solution, and therefore we have our portfolio of ultrasonic fork sensors that we now want to present.